Okay, here's one last example. Similar to the other one, only this one's going to have more complicated vectors. What is the force acting on the 4 microcoulomb charges of this guy? So, once again, we could do a force diagram. So the force of 2 acting on 4 is going to make the 4, it's going to repel, so it's going to go like this. 2 on 4. And then there's also an interaction between these two charges, and force this 3 microcoulomb charge is going to push the 4 in that direction. So there's going to be this force. This is F3 on 4, and we can actually work out that triangle to get that distance. We have to know the distance between these two charges. That's what we're looking for. So if this is 0.15 and this is 0.1 r, so r squared is 0.1 squared plus 0.15 squared, so r is 18.03 centimeters. And this angle there .15, 0.1, numbers 10, 56.31. Okay, so let's calculate these two forces and then add up the two vectors. So I'll start with the F3 on 4. F3 on 4 is K. It's a 3 and a 4, so we got 3 times 10 to the negative 6, 4 times 10 to the negative 6, and it's 0.1803 squared distance apart. Excuse me. So that's already in my calculator. So I'm going to go 9 times 10 to the power 9, 3 times 10 to the negative 6, multiply, 4 times the power of the negative 6, multiply. And now I'm going to divide by that. So I'm going to square this. That's the 18 centimeters, so I'm going to square it, divide, and I get 3.323. And this is the angle. Now I'll do F2 and 4. So K, excuse me, 2 times 10 to the negative 6, 4 times 10 to the negative 6, 0.15 squared. So 99 to the negative 6, 4 to the negative 6, 0.15 squared, divide 3.2. Okay, so now I have two vectors, and I have to add them. So it's going to be 3.2, and then this is 3.323, and that angle there is 56. And I'm looking for the resultant, that thing there. Do I know any other angles? I'm just wondering if I could use the sine law. Yeah, if that's 56, then I don't know. I'm drawing a blank right now, so I'm just going to use components. I'm going to get this thing. This is, I'll call that Fy, Fx. Fy is 3.323 times sine 56. So it was 56.31. Sine. Whoa! 56.31 sine times 3.323. So that's 2.765. And then Fx is 3.323 times cos 56. So cos 3.323 multiply 1.843. So the resultant y is 3.2 plus 2.765. So 5.965. And Rx is 1.843. So this total resultant is the square root of 1.843 squared plus 5.965 squared. Square that. Oops. Oh, what am I doing? 5.965 squared. 1.843 squared. Add. Square root 6.24. And I can get this angle is theta is inverse tan of 1.843, that's this guy, divided by the 5.965. 3. $17. There you go. So that's as hard as a Coulomb's law question could be, really. Actually, there's one other thing that could make it even a little bit harder is instead of saying there's 4 coulombs, I could say, oh, there's like 2 times 10 to the power of 21 electrons. So then you'd have to multiply that by 1.6 times 10 to the negative 19 to figure out how many coulombs it is. Yeah, but yeah, you won't have to do anything quite like with everything at once. Okay, there you go.